Okay, for the introduction in our project, the rotational ball milling is a pulverizing machine consisting of a rotating drum which contains pebbles or metal as the grinding implements. It works on the principle of impact and attrition, which is size reduction is done by impact as the balls drop from near the top of the shell. Then, the steel balls are charged into the cylinder along with the material to be ground and it being rotated. After that, it also allowing the balls to crush the material which travel between them. Without the balls in the cylinder or some other things to crush the material that wish to be grind, little grinding will take the place. After that, in order to ensure the stability of the material in the ball mill and to help narrow and reflect on the final decision, there are some parameters that should be considered such as space constraint, working area, temperature, installation cost and maintenance cost. That's all from me. Thank you.
My name is Sufri Aiman Hakimy bin Sulong alias Mansor. Now I would like to present about literature review. Ball mill is a type of grinder that used to blend or grind material for use in mineral dressing, ceramics and selective laser sintering. The inner space of the cylinder shell usually lined with an abrasion-resistant material such as manganese steel. It also consists of a hollow cylinder shell rotating about its axis. The ball mill is at the picture. Ball mill chose to use gear instead of belting. Due to impact between balls and drum subjected to vibration, there are chances of slipping in belt. There has no intermediation flexible element exists between two shafts, can transmit large torque and power. Gear also can give high speed reduction can be achieved easily. Gear also can transmit heavy power without noticeable problem. And the last one is need less space and more reliable. So the gear is good than belting. There are 5 parameters that should be considered to ensure the stability of materials and help narrow and reflect on final decision. First, space constraints. Second, working area temperature. Third, installation cost. Fourth, engineering solution technology. And the last one is maintenance cost.
Okay, next is calculations. Given in the instructions, output top at min, which is T out, is equal to 1000 Newton meter. And output diameter at min, which is D out, is equal to 2 meter. And output speed at min, which is N out, is equal to 30 RPM. Okay, firstly, we have to find the reduction ratio. Okay, first we find the input speed of motor, which is N input. We got 1500 RPM. It shows that a normal speed of motor with 4 poles is 1500 RPM, but it will run near to 1455 RPM on Lect. We find the mill speed, which is V. We got 3.142 meter per second, and with this we can find the reduction ratio, and we got reduction ratio is 48.5. Next we find the power of motor. Firstly, we have to find the power of motor required for the mills to rotate. So PM we get 3.152 kilowatt. Next we find the output power of gearbox. Consider 99% of coupling efficiency. PG is equal to 3.172 kilowatt. Lastly, we find the power of motor. Consider 10% extra margin for safety purpose, and we get 5 kilowatt.
Moving on to the discussion part, 3 important decisions need to be made to make sure the ball mill works. This includes the what type of transmission system to be used, what types of motor to be used, and also what types of gear reduction system to be used. The first one is the transmission system. Gear drive system is being chosen rather than the belt drive system because it required less space to operate. Next, the 50 Hz motor with speed of 1500 RPM is being chosen because according to some online searches such as growshop.com, it says that 50 Hz is the most common frequency to be used outside the US country. And last but not least, planetary gear is being chosen as the best and most suitable gear reduction system because it has a compact and coaxial arrangement. The table below shows the final judgment regarding parameters to be considered in this project. Thank you.
In a conclusion, the objective of this project has been achieved, which is to find the suitable power transmission system of a rotational ball mill. A discussion has been made among group members and gear drive is chosen as the power transmission system. There are few reasons gear drive has been chosen. The first one is gear drive transmission consume very less space compared to the pulley system. The second one is gear drive requires low maintenance. The third one is working area humidity is in normal ambient temperature. The other one is installation cost is high because it uses high quality material. And the last one is gear drive tip can avoid slipping.